Today we're looking at the best video upgrade you can do for your Commodore 64 or Commodore 128. And for people lucky enough to have the large VIC-2 Kawari or people using LumaCode, you're also going to want to stick around for this one. Even the poor folks stuck using composite video will benefit, even though composite video is shit. What I'm talking about is my RF modulator replacement. Now, for those of you thinking, hang on a minute, haven't we already done this? Yes, I did release version 1 about a year ago. This right here is version 2, and it comes with a number of improvements and extra features in order to squeeze every last drop of video output quality from the Commodore 64 and Commodore 128. So let's get started. We'll start off by looking at how to build one of these. And yes, you can also order one of these pre-made from my Tindy store. Then we'll look at how to install one of these things, how to use them with various other mods that are out there, and also we'll check out the new features on version 2 and of course do some side-by-side comparisons. So let's start with how to build one of these, but if you've already got a pre-made version, you can jump straight ahead using the chapters to the install process. The first thing we need, of course, is some PCBs. There are actually 3 boards here to choose from. The first one is for the Commodore 64 long boards, so the 250, 407, all the way up to the 466. The 326, 298 long board is not compatible with any of these because they use a completely different RF modulator design, but there are some other ways you can improve the output from that machine, and I've done a video on just that, which I'll link to up there. The next one is for the Commodore 64 shortboard, the 250469 revision, and also the Commodore 128 flat and the 128D, the plastic case model. The final board was made exclusively for the Commodore 128 DCR, that is the metal case 128, and that's simply because there were some different tolerances between the metal case 128 DCR and the plastic case 128D. So you'll only want this board if you have the metal case DCR. It will not fit in the plastic case D version. So I'm not going to solder all 3 of these in this video. I actually have a couple pre-made, so we can skip that. Let's just focus on the long board version as it has the most components. All of these boards are super simple to order thanks to our channel sponsor, PCBWay. You can order as many as you like, and you can choose whatever board color suits your preference. These guys make high quality PCBs with a very fast turnaround, so be sure to check the links in the video description and order yours today. We thank PCBWay for sponsoring this video. So once again, just like the previous version, we're just using through-hole components, and they're all pretty generic and very easy to find. There are links in the bill of materials to both AliExpress and a Mouser part list, so feel free to use whichever one you prefer. But I will mention that the S-video connector we need does have a slight recess on it, and this part I can only find on AliExpress. One of the biggest differences between version 1 and version 2 is the routing process. So I've pretty much got everything routed on the top side of the board, which means the underside is just a solid ground plane. But that also means that some of the components are in a different position, so it might not look as pretty as the first version, but once you've got everything soldered in place, I think you'll be pretty happy with the result. I considered doing an SMD version, but decided against it as it's kind of pointless because you need to have this board size in order to get these ports to stick through the rear of the case. I'm sure there's some do-it-yourselfer out there who will take my design and change it to surface mount and then claim it as their own, but I'll worry about that later. So as always, I like to start off with the lowest profile components, so diodes, resistors, and then move up to capacitors, transistors, and then finally the rear ports. So let's cue the music. Alright, most of the components are soldered into place. I have left the S-Video connector till last. Now for most setups, you're going to want to put the S-Video connector there, but for those with the large VIC-2 Kawari, that is the HDMI version, if you want to get HDMI from the Kawari board to this board and then easily out of the case, there is another option you can do. The spot where the S-Video connector normally goes also serves as a mounting place for a micro HDMI connector. And with the use of another HDMI connector and a flat flex cable, you can run HDMI from the Kawari straight out of the Commodore 64 case. Now, of course, the Kawari only carries video signals. It does not carry audio. It's technically DVI over a HDMI connector. So you will still need to get audio out of your Commodore 64, in which case the easiest option is to probably use this 3.5mm jack, which will carry analog audio, and it also supports dual SID setups. I will demonstrate the HDMI output soon enough. For this one though, we're just going to put in the regular S-Video connector. Of course, all these signals are still available on the Commodore 64 DIN output, so even if you put the HDMI connector there, you can still get S-Video from the regular C64 DIN connector. The last thing to do is just solder some pin headers on the underside of the board. Alright, so everything's tacked in. On the groups of 4, I've only tacked in 1 pin on each set for now because these are usually out of alignment, so you will need to line them back up. And if you solder all 4 at once, you're not going to be able to move these things. So I can see this one is definitely pushing to the left a bit too much. Right, I'm happy the 2 groups of 4 are straight. Let's just solder the rest of those in, and then we'll fix up the alignment on the individual headers after that. These individual pin headers are all over the shop. These two look to be pointing inwards, some of them are pointing down, some of them up. So the way I usually handle this is just to put my finger on one side and sort of push the pin header so it'll sit flat on the board with this plastic spacer, and then just heat the top side. You might burn your finger a little bit, but after a glass of concrete, you'll harden up. That all looks pretty straight. If they're just slightly out of alignment, you can usually just bend them a little bit with your finger. They don't need to be 100% perfect, just close enough. Finally, we just need to cut up an extra set of pin headers and just remove the small plastic piece from them. Then you just need to apply them to the individual posts around the outside of the board. For the long board version, there's 6 posts that you just need to install those extra plastic pieces onto, and for the short board and 128 versions, there's just 4 posts. This will just allow the ports at the rear to sit at the right height when it's installed in the case. And that should be our RF replacement ready to go, so let's grab a machine and stick it in, and we might install this as well. Before we go installing this thing, let's just establish a baseline. So I've got a bread bin here. I think this is the one that I fixed on the last live stream. And yeah, it is still missing a few keys, but I'll worry about that later. So let's just push this off to the side and we'll grab some screenshots with the original RF modulator. So this is what composite looks like, and I prefer to use the EasyFlash 3 screen because it shows a lot more detail and also reveals a lot more issues. And this is how S-Video is currently looking. So we'll come back to these later and do a closer examination. Let's whip this thing out. Obviously this is a long board, but the install process is pretty much the same for the short board and the Commodore 128. For the long boards, there are 4 tabs that are usually bent over that just need to be straightened, and there are also 4 posts that need to be desoldered, and these 2 rows of pin headers. For the short boards on the 128s, there's just the 4 tabs that need to be straightened and the 2 rows of pin headers to be desoldered. So let's begin. I'll just straighten these first. And then I'm just going to come in with the desoldering gun and just add a little bit of fresh solder to these as I go, just to sort of get everything flowing. And that should be the desoldering complete. I'm just going to come in and just Sort of jiggle these little pins a little bit just to make sure they're all free. And they all seem to be okay. And then we just need to pop off the old RF modulator. Sometimes they'll put up a fight, and it's recommended just to get something flat and just sort of pop it in underneath the RF modulator. Just sort of lever it up slightly. You can also give it a wiggle at this point just to see if all these pins are moving. Make sure they're all desoldered properly. And after a bit of jiggling, it should come out. Nice. And this you can now throw on eBay for 50 bucks. Just make sure you put rare in the title. Then what we're going to do is drop it in our board. Going to introduce some solder to this round hole over here. The RF board has actually popped back out. But if we have some solder there ready to go, I can just reflow this, push that pin header back through. Add a bit of solder to this side as well. This is where one of the mounting tabs was, so getting solder onto this pin header is a little bit tricky. Doesn't have to be perfect, just as long as you get a tiny bit holding that pin header in place. And we're just going to do a quick test fit, make sure we haven't stuffed anything up. So it'll sit something like that. You can see there's plenty of clearance around this thing to get our S-Video plug in there. So now we can just solder the rest of these posts in place. And that is it. Our RF replacement is mounted. Now before we go closing this thing up, let's take a look at a couple of the features on this board and discuss what they do. For those familiar with version 1, you'll probably notice a number of changes. For example, the composite enable header is missing, and also that little trimmer that was next to it. That's just because with version 2, those things are no longer required. They were sort of a bit of a hack to get the best possible output from composite and S-Video, but thanks to the new routing with this board and the solid ground plane underneath, those options don't really make a difference anymore. The same goes with the external Luma and Chroma connections directly from the VIC-2. The same with the hard reset circuit. I basically ditched that because I don't think anyone was really using it, and it just kind of neatens up the board a little bit. There's not so many pin headers sticking up through the top. So really the only thing we need to focus on is this switch up here and this pin header and this little trim pot just here. Let's start with the switch. So you can hopefully see the switch is labeled 3.5mm right channel selector. That is for this 3.5mm output jack. Basically the left channel will always have SID audio on it, but the right channel you can select between 3 different options. So the first option is you can have composite video on the right channel. So using a little adapter like this or a little 3.5mm to 2 RCA cable, you're basically going to have audio on the left, and rather than audio on the right, you'll have your composite video available there instead. If you want, you can still split the audio out. So if I put another adapter on here, which gets a little bit crazy, then you can have the dual mono audio and composite all off that same connector. Remember, it's safe to split audio signals. It is not safe to split video signals. So while you can run composite out of this jack, you can't also use composite from the C64 DIN connector. My RF replacement will handle running S-Video and composite outputs at the same time, but not dual S-Video or dual composite video. The next option is just dual mono, so you won't have composite video on the left anymore, you'll just have the same audio on both left and right channels. This is probably the best setup for people who are just using S-Video and aren't too worried about getting composite video. Again, the C64 DIN connector will still have that composite video signal available. The final option is labeled external, and that's where this pin header comes into play. So there's a ground connection on one pin and the input connection on the other. This is for people who are using the LumaCode project, which I'll demonstrate shortly. You can basically hook this from the LumaCode board directly up to the RF replacement, and you'll have LumaCode output on the right channel. This is also handy for people who have a dual SID setup, because you can have the regular left channel SID audio and you can run the right channel SID audio to this pin header and have that output on the 3.5mm jack. They're probably the 2 most common uses for this input, but feel free to leave a comment if you can think of something else. Let's check out the video output from this thing, and then we'll talk about how this trim pot works. I'm just going to set this to dual mono output just so I can plug both channels of audio in there, And I'm going to start with S-Video. Let's power on. Hopefully it works. Okay, yes, we have the regular C64 basic screen. Again, this doesn't really give us much idea of what's going on, so let's throw in the EasyFlash 3 cartridge. All right, cool. There is definitely a lot more clarity compared to the original RF modulator, and possibly a little bit of extra jail bars, but I think we might be able to sort that out. One thing we want to pay attention to is the little white space below the EasyFlash 3 text. You can see that there's little yellow dots in between that white area, and with the original RF modulator you couldn't even see those yellow dots at all. This is where our little trim pot comes into play. So if we turn this all the way to the left, you can see those yellow dots are now clearly defined, but the white doesn't look as white anymore. If we turn this thing all the way to the right, we can see white has now bloomed out to the point where you can't even make out those little dots anymore. So this is kind of what the original RF modulator looks like, and this is just a bit of a flaw in Commodore's RF modulator design. So that's why I've added this trim pot. And you just want to adjust it to the point where white looks white, but it's not blooming and overtaking the other colors in between. Another thing this does seem to affect is the jail bars to some extent. So ideally you want bright white and minimal jail bars. So just spend a little bit of time tweaking it. If you end up replacing the VIC-2 in your machine, you're going to have to do this again. And that is because every VIC-2 will output a slightly different luma to sync ratio. Now, Commodore didn't worry too much about that. They just use a single fixed value component, but I've added the ability to tweak that. To my eyes, it looks best somewhere around there, but again, this is going to vary from machine to machine and VIC-2 to VIC-2. Another way to set this up would be just to change the foreground color to white in basic, and let's change the border color to say light gray. And then you just adjust this to the point where white looks white without blooming out the text. And obviously the light gray shows the least amount of jail bars possible. Something around there looks about right, and I think that's very similar to where I had it before with the EasyFlash 3 cartridge. Of course, you can load up your favorite game and do this adjustment there if you prefer. Again, if you end up replacing your VIC-2, you're probably going to want to make that adjustment again, but apart from that, it should be safe to leave it alone once you've found the ideal position. So let's see how this works with the LumaCode, and then we'll finally take a look at HDMI output from the Kawari. So here we have the LumaCode board, or the VIC-2 dizer as it's called. I have done a video on this already, so I'll throw a link to that up there. Basically, it's a little interposer board that sits between the VIC-2 and the VIC-2 socket on the main board, and this creates its own quasi-digital video signal based on what's going in and out of the VIC-2. And that gets routed to a separate board, which is basically the RGB to HDMI, but with the LumaCode input. And from there, it uses a Raspberry Pi to give us a HDMI video signal. So let's pop out the original VIC-2, and we'll stick this in its place, and then put the VIC-2 back in the top. And this board has two outputs. So on the board it says Luma and ground. So our yellow wire is currently the Luma wire. So that's going to connect to the input on our RF board. And the ground wire is obviously going to connect to ground. Now, having these alligator clips like this isn't exactly ideal, but it's good enough for a test. So let's switch this over to external input. And I've got everything hooked up. Oh, we of course need to take the right channel audio off and stick in LumaCode instead. And that's what goes to our little Raspberry Pi. Power this on and we should get something. Yes, there we go. Pixel perfect Commodore 64 using the original VIC-2 and the LumaCode board. Let's have a look with the EasyFlash 3 cartridge because that'll reveal a bit more detail. And yeah, that looks absolutely perfect. You couldn't really ask for better than that. And the LumaCode does still output the regular S-Video and composite signals, so you can still use them as well as the LumaCode. And because this is creating its own video signal, it's not affected by this trim pot here or anything else on my RF board. This just provides a convenient way to get it from here and then out of the case. So I think it's probably better to get rid of the alligator clips that the LumaCode normally comes with and just use a couple of female DuPont connectors. And that way they can just plug straight into this side, making sure to match up the ground and the input wires correctly, and probably just put a little twist in these just to mitigate any, stray signals trying to make it into these wires. And yeah, that works perfectly fine. I probably could shorten this cable a little bit if I wanted to. So that's one way of using the external input. As I mentioned, the other way would probably be with a second SID, so you could have both left and right channel audio. Let's have a look at the HDMI Kawari. So this is my Australian Commodore 64, and it's basically just a regular longboard inside. I've already removed the RF modulator, and this one does have the ARM2 SID, so we can also demonstrate dual SID audio along with our HDMI output. So with the board removed, let's prep the RF modulator replacement. So in this case, I haven't put the S-video connector on, and instead we're going to put on a HDMI connector. So it is this little one here. It's a micro HDMI, and it pretty much sits on the board, and you should see it line up with these two holes at the front. So what I'm going to do is just put a little bit of tape over the original S-video connectors, because this board has a bunch of little vias on the bottom and we don't want it shorting out to any of that. So I'm just going to stick a tiny little bit of Kapton tape over the bottom half of this board, making sure those two solder points are still exposed. And that should be ready to go. I'm just going to add a little bit of fresh solder to these 2 points just to make it flow easier when we try and solder it to the RF replacement. There we go, just a tiny bit, not so much that we have a big blob of solder on there, just enough to sort of get that thing prepped. And then all we need to do is flow some solder into one of these vertical holes, line up our little HDMI connector so we can see the port through the other hole, and so that it's flat against the edge of our RF replacement. We're just going to get that solder flowing, and that should flow down to the actual board itself. And yeah, that is now in place. A little bit crooked, so I might just touch that up. And yes, that HDMI port is getting very hot. That looks good. We'll just flow some solder into the other hole and wait a couple of seconds, and we're good. All right, let's see how this fits with our Australian Commodore case. The audio port sits a little bit high, but I'm actually using the wrong audio connector here. This is what I used for the first RF replacement. The new ones have a lot lower profile audio connector, so you can see the difference between those two. All right, that is now soldered into place. Let's reinstall this in the case. The final piece of this puzzle is just a 15cm flat flex cable and a male HDMI connector. So just undo the bails on this thing and put in the cable with the connections facing up. Close the bails on that side. And do the same on this side. That is it. This just plugs into the VIC-2 Kawari. The other way up. Done. Now these parts I got from AliExpress. I couldn't find a supplier that stocks these particular HDMI connectors, but you'll find links to these in the bill of materials for these boards. The shortboard versions and the Commodore 128 versions also have those two holes in the board, but keep in mind the VIC-2 Kawari is currently only recommended for the longboard Commodore 64s, and such a thing doesn't even exist for the Commodore 128s. So even though those holes are there on these boards, that's more just wishful thinking or perhaps future-proofing on my behalf. Hopefully one day we'll have a solution for them as well, and we'll be able to take advantage of HDMI on these little boards. And while we're at it, we may as well hook up the second SID audio to our input. I think these ARM2 SIDs, I'm pretty sure the connector also had a ground pin coming out of it, but I think I took that out and lost it somewhere. It's not a big deal. We're still going to have a ground connection from over here to over here and obviously everywhere else. So no worries if the ground pin is not populated. Sorry about the random pause, slight technical difficulties there. The VIC-2 Kawari doesn't output a standard HDMI resolution, so I had to play around a little bit with the capture setup, and then I thought it might be my HDMI connector on the RF replacement. Turns out it was just a weird incompatibility with my capture device, but that's all sorted now. So yeah, if you're having issues, definitely make sure that you can get HDMI directly out of the Kawari before you go worrying about the connection to the RF replacement board, like I did. Cool, so that all looks good. Let's load up a dual SID track because we can test that out while we're at it. Cool, there we have it, the VIC-2 Kawari with HDMI output going straight to the RF replacement, and of course the second SID going to the RF replacement as well. So that does certainly provide a convenient option if you want to sort of maximize your mods here. Of course, you can always add a HDMI audio embedder. I've shown those in the past, and that way you can route both the audio and video into a single HDMI cable, which you can then plug into your display or capture device or whatever. But otherwise, analog audio works as long as you've got, powered speakers or a separate amplifier. Right, and last but not least is the Commodore 128. This is a Commodore 128D, so the plastic case version, not the metal case DCR. So this uses the same board as the Commodore 64 short board replacement. And of course the DCR has its own dedicated board. Let's just throw in the Easy Flash cartridge just so we can set up the white levels easily. And you can see that, yeah, it is quite bloomed out. It's looking very bright. So I'm just going to turn this down a little bit. That's looking better. Let's see if we can tune out some of those jail bars as well. Yeah, that's pretty good. Pretty good for a 128 anyway. Let's have a look at the main screen. Yeah, you can definitely see those jail bars still. Now there is one little feature that I added just for the 128, and that is an optional jail bar filter. I don't recommend populating this by default, but if you want to experiment with it, you just stick in a 1 nanofarad capacitor, making sure not to push it in too far, otherwise you'll short it out to the main board. And you can see the jail bars have been reduced, but the image is slightly softer, and that's basically what this filter is doing. It's a low pass filter, and it's going to smooth out those jail bars, but it's also going to soften the image at the same time. So that's why it is an optional filter, and I wouldn't recommend installing it by default. But if you like the look of it or really hate the look of the jail bars, then that's an option. So I think that is it for these RF replacements version 2. Like I said, I will be selling these on my Tindy store. Alternatively, you can build your own and source all the components and all that jazz. Totally up to you. And I'd like to give a massive thanks to my patrons who, without their support, none of this would have been possible. So a big shout out to you guys. And of course, thank you all for watching, liking, subscribing, and sharing these videos around. And I hope to see these being installed in more machines. So that is it for this one. Thanks for watching. Bye.